Okay, so for this video, I want to take a look at being able to create our own custom exceptions, as well as being able to throw exceptions explicitly in our programs. So to start off with, I first want to take a look at creating a program where we just want to set up one of these throw statements to be able to just throw an exception whenever we might need to in our program. And then I want to modify the exception that we're throwing to, instead of being one of the exceptions that already exists as part of our Java API, I want to go ahead and create our own custom exception and throw that instead. So for this program, we're going to go ahead and make a new program or a new project. And the way that I'm going to approach this, I want to take a look at dealing with output to a file. So whenever we're using, say, the printWriter class, for example, so we're going to make a project called output exception demo. So we're going to do public class output exception demo. And for this one, what I'm going to need is all of the files, or all the classes from the IO package, as well as the scanner class from our util package. So we'll go ahead and grab both of those imports, and we'll also go ahead and set up the main method for this. So we're going to do import java.io.wildcard, and then import java.util.scanner. Right here, we'll go ahead and make our main method. So we'll have our public static void main, string array of arguments. And inside of here, we'll go ahead and set up, in this case, two variables. So one of these is going to be a scanner for the user's input. So we can go ahead and specify the name of a file. And then the second one is going to be a string to hold the name of the file that they give us. So we'll have our scanner, call this keyboard, is equal to a new scanner object that we're going to use to read from our standard input, so coming from system.in. We will then go ahead and make a string for the name of the file. Just go ahead and make this initially an empty string. The next thing we can include is our request to the user for the name of that file. So we can say system.out.print. Please enter the name of the file. And then what we're going to need is our try catch. So in this case, to start off with, I'm just going to go ahead and make a try with resources. So I'm going to do try, and then we're going to go ahead and make the printWriter. So this will be for my output file. It's going to be equal to a new printWriter. And for this one, I'm not too concerned with whether or not it can append or overwrite, so I'm not going to worry about creating a file writer to go with it. Instead, I'm just going to go ahead and put in the name of the file with this printWriter. So we're going to put that here. Also, just above this, we want to make sure that we're actually getting that file name from the user. So I'll say this is equal to keyboard.nextLine. We can go ahead and grab that from the user's input and then actually put that in right here to construct our printWriter object. I'll go ahead and have the body of this try. So what I want to go ahead and do for this one, it's very simple. I just want to go ahead and once I've created that printWriter, use that to write a single line to the file. And in this case, we're just going to go with the simplest example. So we're just going to print hello world to this output file. And then what I want to be able to do is just catch any exceptions that might occur. So I'll just say catch any IO exception. Call it E. And then we'll have a print statement for the console. And we'll just go ahead and get the default message that comes with it. So we'll just say e.getMessage there. Okay. So right now, the way that this is set up, we're just going to ask the user for the input. In this case, it's going to be the name of the file. We're going to construct that printWriter object and then write to the file that is connected with that printWriter. And the way that the printWriter works is that if the file doesn't already exist, it's going to go ahead and create that file for us and then write to that file. Whereas if the file does exist, it will go ahead and just find that file in the location that we specified, so whatever folder or directory that we happen to be in, it will find the file inside of there, open that up, and then write to it. So right now, if we go ahead and run this, so we'll go ahead and compile it. This is going to be our output exception demo. So we can compile it just fine, and then run it. So if we enter the name of a file, so in this case, we've got a file called hello.txt already. So for this one, I'll come up with a super clever name and call it hello2.txt. So if we do that, we don't get any exception because of the way that the print writer works. So there's no, say, like a file not found exception. So if we come over here, we're going to see hello2.txt. If we open that up, we can see the phrase hello world written to it. So ideally, I want to try to reconstruct this in a way where the print writer is only ever doing exactly what the name of this class would imply, which is writing to a file. I don't really want to give it this additional behavior of constructing the file if it doesn't exist. So I want to go ahead and add a little bit more to this so that it doesn't do that anymore. So what I need to go ahead and do is also do a quick check to see whether or not the file that I'm trying to access to write to, if that file even exists in the first place. So to check for that, I'm going to go ahead and take this file name that I get and use that to create another file object. And then later, whenever I want to do this, we'll go ahead and use that same file name to make our print writer. So right here, what I'm going to go ahead and do is say file, making the variable name lowercase f. This is going to be equal to a new file object. And we're going to pass in the file name right here. Okay. Then what I can go ahead and do is just do a quick check and say if the file that I just created, we're going to say if it does not exist, then I want to go ahead and do something right here. And the thing that I want to do right here, this is where my throw statement is going to come in. So what I want to do is just say throw file not found exception. Okay. But in order to do this, I want to go ahead and make sure this is a constructor and actually create a new object here. And the reason that I'm doing this is because, as I mentioned before, whenever we deal with exceptions, so these names that we see are the names of classes, and say when we're dealing with a catch like this right here, we see that we have a reference variable in our catch. So like this reference variable, it has the name E, and so the thing that we need to reference is going to be an object of some exception class. So whenever we include one of these throw statements, the thing that we are creating right here, that needs to be an object that we are constructing of whatever class this exception is going to be associated with. So like in this particular example right here, the expectation is that maybe somewhere in this code, there could be some kind of problem that occurs that's going to cause it to construct an object of either the IO exception class itself, or maybe one of these subclasses like this file not found exception. So now that we've got all this, I want to be able to throw an exception, but I can't just do that just right here like this. There are one of two things that need to be occurring. Either I need to make sure that this is placed inside of a try block, kind of like what I've got right here, or I need to make sure that there's a throws clause in my method header. So we're at the point now where I don't really want to be using throws clauses. Instead, I want to be handling this in a more, I'd say a more robust way. So what I'm going to go ahead and do is just create another try right here. And so for this one, this will not be a try with resources. And what I want to go ahead and do is just take all of the code that I've written so far right here. I'm just going to go ahead and place all of that into this try block, like so. And so now what we're going to be doing is we're going to create a file based on the name of the file. We're going to check to see if it exists. If it doesn't, we'll throw this file not found exception. If that's all good, then we're just going to go ahead and enter another try catch block. So we're essentially going to have nested try blocks right here. And instead of this one, we're going to go ahead and actually make the print writer object so we can go ahead and print something to that file. And the particular reason that I want to do everything in this exact order is because if I let this print writer go through in this try with resources, and then I go ahead and do this check, I run into a bit of an issue if I swap that order, in that the print writer will, as soon as I construct this object of the print writer class, that will immediately create the file for me. So I want to be very careful about not accidentally putting these in an order that will cause that to happen. So I need to go ahead and do the file first and then check it. As it turns out, for some reason with Java, they decided that if you create a file object like this, that doesn't also create the file within your folder or your directory. So doing it in this order will cover everything that I'm trying to accomplish here. The last thing I need to go ahead and do, since I've got this whole try block here, I also need to make sure that I have a catch block to go with it. And so right here, what I need to catch is this file not found exception if that gets thrown. So we're going to say file not found exception. And we'll go ahead and just give it the same name. So within the scope of this catch block, we'll just call it E as well. And then right here, we'll say system.out.println. And for this one, what I want to go ahead and say is output file not found. And we'll say output was not written to the file. Okay. So at this point now we'll be able to see that this is specifically talking about when we couldn't find the file in relation to using the print writer. And then what I'll go ahead and do is remove this folder, or this text file that we have right here. So we'll go ahead and delete that and close this from my text editor. And then if we come over here, we'll go ahead and compile this again. We'll go ahead and run it. And this time, if I put in the name of this file, say hello2.txt, we'll do that. And instead of getting nothing like we did before and just automatically wrote to the file, instead now we're getting this warning saying output file not found, output was not written to the file. If we then come over here, we'll also see that hello2.txt, that text file, was not created. Okay, so this is a pretty good example of a situation where you might consider including the ability to throw an exception like this explicitly. It is important to keep in mind, though, that not every situation where you encounter some kind of error from the user would justify using a throws clause like this. Certainly not, or a throw statement like this, and certainly not if you also just used a throws clause in the method header. If you're instead relying on that and these, you do run the risk where you're introducing a bunch of potential exceptions that you'll throw that cause the program to terminate there, when in actuality what you might intend to do is throw this exception, catch it, and then try to recover from it in some meaningful way. So one example here, if you had considered it, another possible way you might approach this is that if the user was trying to write to a file, but they couldn't actually find it, in some cases, it might make sense that you would just create the file for them and then go ahead and write to it. But considering that the intent here is to demonstrate going against the default behavior of the print writer class, for this example that I'm using, we'll go ahead and not actually do that. So one other thing that we can go ahead and take a look at here. So we see using this explicit throw statement to go ahead and throw a file not found exception. But let's say that I want to go ahead and create my own version of file not found that is specific to dealing with the print writer class. So dealing with not creating a file when we're trying to use print writer. So let's say I want to go ahead and make another Java file to go with this. So if you've got a project in an IDE, you just go ahead and create another Java file in your package. And for this one, I want to go ahead and create my own custom exception. So what I'm going to create is going to be called output file not found exception. This will be a Java file. And so we're going to say public class output file not found exception. And whenever I want to create my own custom exception, I need to make sure that this is going to be extending, or that it's going to be inheriting from the exception class. Okay. There are two reasons why this is going to be useful to me. One is the ability to get whatever the default message is for the exception that I'm creating, and the other is to make sure that I can actually throw it, because as we mentioned a little bit before when we were talking about the hierarchy for our exception class, we mentioned that exception itself will inherit from another class, that throwable class, and because it inherits from that throwable class, that's the reason that we're going to be able to use it with this keyword, this throw keyword here. So what we can come over here and do, the only thing that I need to include in one of these custom exceptions is just going to be a constructor, and the only thing we're going to specify in this constructor is going to be the string for its default message. So I'm going to say public output file not found exception, and in order to set up this string for its default message, we're going to make a call to the exceptions constructor. So we're going to say super. And right here, we're going to put in, let's go ahead and just use this message that I had right here. So I'm just going to go ahead and take all that, go ahead and cut that out right there. come over here, and we'll go ahead and paste it in right there. Close that off. And so now, whenever we want to get the default message, so when we use that getMessage method, it's just going to print out this statement right here for us. So then we'll come over here, and so now anywhere where I'm using the file not found exception, instead I want to go ahead and use my output file not found exception. So we're going to say output file not found, and right here as well, output file not found. And then right here, I'm going to go ahead and take this variable that I'm specifying. So it's going to be that e dot, and then we're just going to call that getMessage method again. Okay. All right, so now that we've got all this, we'll go ahead and compile it. So we'll come over here, we'll go ahead and compile this, and then we'll run it, and we'll go ahead and try the same thing as before. So we'll just say hello2.txt, and we can see now we still get the same message, output file not found, output was not written to the file. So now we're getting that same statement that we got before. The only difference is that now we've created our own custom class to do this for us, and I've also managed to just go ahead and set it up so that we can just get that message using this method instead of rewriting that statement anytime that we want to be able to catch some kind of exception like that. And then of course, if we go ahead and just create that file, so we say hello2.txt. So if we go ahead and make the file, if we run this again, and we put in hello2.txt, now we don't get any message here since it went ahead and just wrote to the file and didn't give us any warnings about that. And if we come over here, we can now see that phrase hello world written to that file. Okay, so this is going to wrap up everything for exception handling as far as being able to use these try catch or try catch finally or try with resources blocks, as well as taking a look at being able to throw exceptions explicitly or create our own custom exceptions. Going into the next kind of half of this set of videos, so the next half related to chapter 11 of the course book, we're going to start taking a look at different topics related to advanced file I/O.